Good morning, America, and welcome to the Physics Network. I'm your host, Zach Hoover, and today's top stories deal with magnets and how they can be used to conduct electricity in the home and the world around us. RJ in the Newsroom will explain more on this riveting topic.
Thank you, Zach. Two prominent men, Lenz and Faraday, theorized on magnets and their influence on electrical circuits. Faraday's law states that the induced electromotive force in any closed circuit is equal to the negative of the time rate of change of the magnetic flux through the circuit. Lenz's law states an induced electromotive force always gives rise to a current whose magnetic field opposes the original change in magnetic flux. These two laws help us understand magnets and their influence on electrical circuits. Back to you, Zach.
Thank you, RJ. Now our first guest is an expert in a product known as the hand crank generator, a simple tool used in many homes to generate electricity when the grid goes offline. Here we have Professor Trevor Hansen to discuss the hand crank and show us his model. Professor?
Here I have created an example of a hand crank generator using 8 neodymium magnets and 2 coils connected in series to power this LED. All I did was make a simple frame out of wood, plastic, glass, and metal to host these magnets, in which when spinning creates current by applying Faraday's law of induction. How I constructed this drum of magnets was by simply just placing the opposite facing poles in each and every other slot. You can see the opposite poles are at each and every slot if I place this magnet here. Not sure how well you can see that. Anyways, by designing this, I used the concept of Lenz's laws, which states an induced electromotion force always gives rise to a current whose magnetic field opposes the original change in magnetic flux. At every eighth of a turn, I have a complete reversal of the poles, in which affects the core of the coils to create a strong flux change in the center. Thus the coils give a stronger voltage in return using Faraday's law, which gives us the equation that voltage is equal to the negative amount of turns of wire times the change in flux, which is a lot because of how I designed these magnets to alternate their poles so quickly over the time of change. So when I spin this to create a large change in flux in a short amount of time, see the light bulb lights up. All these coils here on each end are wrapped around about 500 times. It generates about 2 volts of electricity while spinning them. And when you spin them, you're only spinning them about halfway each time. And it still provides enough electricity. I had no pulley system. I didn't have to do anything to it to make it spin a lot faster or anything, just because of how quick they change their poles. And I can still produce 2 volts of electricity with 2 of these coils. Just to summarize again, what's happening overall is that I got these 8 neodymium magnets, which each of them have a pull force of about 27 newtons. Spinning about the axis, and with every eighth of a rotation a new pull direction is introduced, thus changing the flux that goes through the wire. The core strengthens the flux that goes through the wire, giving it a greater change when the poles alternate. These wires then, opposing this change in flux, creates a current that, by following Lenz's law and Faraday's law of induction, we know will give us a good voltage. These wires connect this circuit and the coils in series, which leads to this light bulb, which gives us about 2 volts of electricity. It's just as simple as that. Changing the flux by changing the field direction that goes through the coil. That's your electric generator. And while I'm using a hand to turn this generator, this is the same design concept for all other generators out there. All you need for a generator is a rotating field or changing field next to a coil facing that field. You can use anything that applies a force to turn these axles. Another way electricity could be produced is through hydropowering them, like simply using the flow of water from a dam or river that could provide a pushing force for these magnets to rotate. And then you have a simple source of clean energy.
Thank you, Professor, for your riveting examination of the hand crank generator. Our next guest is going to speak on a topic that holds much similarity to the hand crank generator, but uses water power instead of human power. A fascinating concept indeed, and we have Dr. Margaret Anderson here to tell us about hydroelectricity, a necessity in many cities these days. Doctor?
Thank you, Zach. A hydroelectric dam is similar to a hand crank generator in the sense that instead of using your hand to crank the generator, water in the stream does the cranking. The hydroelectric dam works like this. Water, on the base of the dam, flows through the tunnel that reaches the turbine. The force of the water spins the turbine, and the water goes down vertically before being released downstream, creating a motion that is not unlike flushing a toilet.
Thank you so much for your time, Doctor. It was a truly fascinating topic indeed. Ladies and gentlemen, with these products and through the power of physics and the laws of Faraday and Lenz, our society is able to thrive off of the electricity that is produced by the generators we have seen here today. Thank you for joining us on the Physics Network. This is Zach Hoover saying goodbye and good night.